Welcome to a new test and teardown video. This time it's a Farnell pulse generating system, and it doesn't really have a number as a whole unit, at least not here from the front. But what I can see is all the individual modules. They got some sort of names, at least with some shorts like this. And the first one is, of course, the power supply number 1. And maybe it's just this FI. I don't know exactly. Maybe there was supposed to be a little extra something down there, but it's this number, the two letters there, also go again on all the other. Well. The fun thing is also, can you look at this symmetry here? You can see we got 4 modules here, and they repeat once again. So those 4 modules here, they are exactly the same. So I think all the different modules there may be individual, and then you just can connect, because here's a trigger input. But where's the output from this one? So I don't understand. Maybe this activates one of these 3 or something. So here's a synchronization output. And there's another output. So, and there is a few other really funny things I want to show you. This is the bottom part of the instrument. It looks like all the different modules, they can be pulled out from the bottom just using one screw. Isn't that a little bit amazing? So I flipped it all the way up. It also looked like, oh, okay, this I need to fix. Look at that. Mains cable, whoa, completely smashed. It's totally flat. Oh, you can even see half of the... This was maybe warm or something. Oh, it's probably not safe to use that cable. Yeah, we should try and open and do a little bit deeper inspection. It's not happening all the time, but this is one of those days. See the 2 screws here at the bottom, they are nice and loose and easy to access. There's a little bit of a special weird locking thingy here, but this one is not moving, and I took the biggest and baddest screwdriver I got that fits perfectly, and look at that, I messed up the screw and it's just not moving, and I gave it a ton of power because I really wanted to try and take the cover off so we could enjoy all the modules from the top. That is not going to happen right now. So I'm trying to attack this a little bit differently. Look what I figured out so far. So this bracket here grabs the front of this, clickety lock in place with 2 screws on the side, and then we got the screws here at the back. So now I should be able to pull out each of the modules, but that is not happening for whatever reason. Now I'm looking through all the holes and the little cracks here, and I'm trying to bend this out. Now I can see wires going between the modules. I mean, oh no, I am locked in a corner here. So I need to figure out what to do. And we are in. It turns out, of course, how stupid is that? I just feel like a complete muppet. I mean, look at that. Now I got these little thingies down there. I don't know how to pull these up. So they are press-in clickety thingies. And for whatever reason, they also lock so they don't turn around. They are held in place for some reason. And that means you can also unscrew the bolts except that one, they put some glue or some stuff in there. So, but anyway, we are in. I will try and fix that later. How could I know that you need to pull it open or crack it open somehow? But now you know, guys, how to open this thing. At least you get this. So now I understand why I couldn't pull the modules, because the power supply is wired to a power everything kind of a system, and some of them uses more colors than others. So if I need to take this one out, for example, I need to pull, see? You can just pull these little connectors out like that, and then you can easy. This one is a little bit loose. Ah, look at that. So that is how it works. And then here you can reconfigure how every little module triggers this or trigger that. So it looks like the 4 modules here, they are not connected to the other one, but just earth. And I bet you don't need to do that, but they did. So all the earth wires, they are connected together down here, but of course they are also connected in the power supply anyway, right? I really want to try and take some of the modules out and see the build quality. So if you wonder why you can't pull the modules out from the bottom, that is because we also got screws here at the top to all the modules. Okay, let's try and make this very, very complicated. That is absolutely beautiful. I really love that they didn't try to make it as compact as possible and real difficult. So 1 layer circuit board, and the earth is also the chassis and signals in and out on the front, and it's all the black earth here, and it's also ground on the power supply. So everything is definitely connected good and safely together. We got everything here neatly numbered and named and all the nice things. So that is the transistors. I mean, let's look at the, oops, like that. The circuit board here is called A2063, and there's a DJC, and that is all. There is really, really big fat tracks. I mean, they're like 3 millimeters wide or something like that. Amazing. So this is the next one, and this one is called pulse delay. So we got microseconds to milliseconds, 0 delay, single and double pulse, and multiplier. Can't wait to try and power this up and see exactly what that means. And it's all transistor based. And I think most of the intelligence here lies in the switches that connects to some capacitors and all the resistors. And then it goes to all these, and then look at that. See what I'm saying? We got all the resistors and all the capacitors. They just go in these sets, and then it just affects the transistor systems like that. And then it can just do some pulses, and that is kind of just all. And this one is just called pulse width. A lot less features, 0.1 microsecond to 100, and then some multiplier. That is just what we got here. And a little Zener diode and a transistors and stuff like that. And again, we got capacitors and resistors connected down here. They really like it big and clean. Yeah, look at the layout. It's just tape on transparent film again. Wonderful layout. And this is the last one of the modules or signal units. Output unit, plus or minus pulse, and the output can be all the way to 20 volts, an attenuator and all that kind of stuff. So the input to this module is of course here, and that was connected to the previous pulse width. So all these things we just need to know. 3055 and another 3055. Ooh, interesting. Some driver transistors. RCA. This is just BFX8080. No, yeah. 88 is what it's called, and I was like trying to see if I can get some date codes on any of these, but that is not so easy. We haven't yet figured out how old this is, but I really think this is old. Maybe there's a little bit more to see in the side there. Power supply, that is the last one we haven't really been looking at. Again, the JDC logo there. Let's look a little bit at the power supply. I really like the way that it's fused both on input and all the output individually like that. It's very, very good. One could think about this could be like a kit or a super development system where you could modify everything, because it's really designed for super easy manufacture and poke around. I really wish that you could just buy these empty modules with this. It's really, really a good design to build in your own plug-in modules and all that. So the power supply looks very, very traditionally. Can't really find the rectifier bridges, but they are probably on the other side. We got something here. This is mirrored, so it should be 68. And I found it also here. Yes, here it is. May 68. So now we know, now we have a good guess about the age of this module. So it is really that old. And that will be all the 4 power supplies they are really using, 3055s. And all those diodes, that will be the rectifiers, variable outputs and everything. But I mean, I don't see any leaked components anywhere, and no brown or blown up anything. The only thing that worries me is this cable here that's completely flat, and I can see half of the red wire in there. So I better see if I can change this somehow. Sometimes they're really difficult to get out of these, but it looks like this cable here is a little bit thinner than normal. So I will have a chance. I wanted to inspect the fuses because this tells me also a lot about how things is going. But look at that, it's full of nasty corrosion all the way in here. This is not good for a good safe contact. And also look at that, completely nasty. But I think it has something to do with the zinc coating. I've seen this a million times with fuses. They just go real nasty like that. This is a little bit funny and probably worth to share. So this is the mains fuse, a tiny little one. So this is 16 millimeters. The next one here is the 25 negative and 25 positive. They're using different fuses. I think it's because this socket accepts both 16 and 20, because it doesn't really matter because they got a real long fuse, or maybe it is really designed for the small one, but you can press one of the larger one in if you really want to. And see, it's a brand thing. This particular brand of fuses for the plus 5 volt, they corrode really, really bad. So I don't know how to fix that, or maybe replace these. So I think I was able to get this thing up and running. I had a lot of problems with the fuses, and that was actually what causes everything not to work. And what I really miss of this on this product is a little LED or indicator or whatever near each of the 4 output voltages. That could have saved me a lot of time, but of course it's available on the back, but then you need to pull it apart and all that. But let's just play a little bit with this thing. So that is here the 4 modules to the right, and I have now zoomed in a lot on the time base. The green one is the input signal, so my synchronization input, and this one here is a sync output from this module that tells that now this one has activated or pulsed, triggered on your input. And then we can try and zoom out and see what this thing here is doing. See, at the moment we got, this is the purple signal, this is the output here. See, we got the attenuator, so we can make a nice powerful signal. And let's just turn off. This one is not interesting at the moment. So we can pulse positive. Oh, where's the negative? So that don't seem to be working, but okay, positive pulses seem to be working. So we have a multiplier here that says the width of those 2 pulses, and we can see tiny little pulse, and then, well, we got a little bit of noise in this potentiometer. As long as they are within this time frame, I have set it for double pulse. If I say single pulse, then it goes here, but it starts somewhat after. And that, I believe, see, is this potentiometer here that says that pulse, and you can of course change this to whatever you want, as long as you are within your time frame. So we got a variable delay, single pulse, double pulse, 0 delay. Oh, that is weird. Okay, here we go. So the double pulse needs to be, of course, after that pulse, and then you get 2 pulses. All right. And there you have your 2 little pulses. So now I can do double pulses here. Tiny little double pulses. Well, so this thing can do a lot of pulses, and variable this and variable that. What do you think about that? I just don't know. What can I use this for? But this was definitely a thing in 1968 or something. Oh, please tell me exactly what was the main purpose of this thing, to do some pulses like that, but it definitely looked quite expensive. So thank you very much for watching. See you around. Bye bye.